In section 8.3, we're going to work with circles. So our learning objectives here are to be able to graph circles and to write the equations of circles. Key vocabulary: circle, center, and radius, all things that you should already be pretty well aware of. So these are the major center and the radius are the major parts of a circle. And let's go ahead and look at how those play out, though this should be review for you. The equation for a circle is x minus h squared plus y minus k squared equals r squared. And this again is a derivative of the Pythagorean theorem. So if you take a look at this, we know that the center is this point here in the middle. And the distance from the center, again we're talking distance on all of these measurements, distance from the center to any point on the circle is the radius. So when we go ahead and graph a circle, what we're going to want to do is find h and k to locate our center. In the simpler form that we have up here, h and k are both equal to 0. So this would be a circle like this one that's centered at the origin. But there's no guarantee that that's where my circle will be centered. So then I would probably use the distance formula if I was given a point on the circle to find the distance from my center to the point on the circle. That would supply me with my radius. Or I might just take the square root of this if I was given the equation. And once I have my center, I can go the simplest distance, which would be up, down, right, and left, where it's simpler to measure as opposed to on a diagonal, to make my 4 points, and then I can draw my circle. So if we take a look at this, I know that h is equal to 0 and k is equal to 0 because there is nothing being subtracted from x and there's nothing being subtracted from y. So my center is at 0, 0. Remember, my center will always be at h, k. Okay, if I look at my radius, it's going to be the square root of 25, which is 5. So if I go up 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5, right 5, 1, 2, 3, 4, 5, and left 5, 1, 2, 3, 4, 5, then I have a circle. So let's see if I can get my circle to be about the right size. Yeah, that wasn't a bad guess. There we go. Okay, so we want to identify h and k so that I can find my center, identify my radius, plot 4 points, draw my circle. Okay, let's do that one more time. You're going to get some problems like this where it's not in the correct form. Sometimes in the forms that we see the equations, it's difficult to tell what it is. The sign that it's a circle is that this coefficient and this coefficient are the same number. If they were different numbers, it would be an ellipse. But for now, we haven't started working with ellipses. We know that if I divide both sides of the equation, I'll get x squared plus y squared equals 192 divided by 8. So that'd be 24. 160 and 32 is 192. Okay, so I know that my center is at 0, 0. I know that my radius is equal to the square root of 24, which would be 2 radical 6. Okay, factoring out 24 is 4 times 6. The square root of 4 is 2. The square root of 6, I don't really know. So it's going to be a little less than 5, right? We know that the square root of 25 is 5. The square root of 24 would be just slightly less than that. So here's my center. 1, 2, 3, 4, and almost 5. 1, 2, 3, 4, almost 5. 1, 2, 3, 4, almost 5. 1, 2, 3, 4, and almost 5. And again, if I grab my circle, something close to this, I think. I'm guessing good today. There we go. Okay, so if we look at this when we're not centered at 0, 0, Now I need to find h and k. So in this case, h is equal to 2, k is equal to 7. So I know that my center is at 2, 7. My radius will be the square root of 9, so that would be 3. So I'm going to go to 2, 7, 2, 1, 2, 3, 4, 5, 6, 7. And then from my center, I'm going to move by the distance of my radius. 1, 2, 3 to the right, 1, 2, 3 to the left, 1, 2, 3 up, and 1, 2, 3 down, and draw my circle. And there we go. Okay, so nothing really changed. I did the same steps. I found h and k, I put them into my center, I found my radius, and I created my 4 points. Okay, so go ahead and practice that. Do problems 9 and 18 from 8.3 and problem 8 from 8.6, and then come back and we'll write some equations. So when they supply me with information to write the equation, so they're telling me I have this as a radius, this is a different circle, I have another radius. Write the standard form of the equation of the circle with the given radius whose center is the origin. So in each case, h is 0 and k is 0 in each of these cases. And this is very simple. So I'm going to have x squared plus y squared plus, equals 5 radical 2 squared. So 5 squared is 25, radical 2 squared is 2, 25 times 2 is 50. So x squared plus y squared equals 50. And in this case, x squared plus y squared equals 16 squared. And if I wanted to, I could square 16 and put that number. I squared this one because it's more appropriate to not have the radical in my problem. That's why I took the time to do that. So now we have a slight variation here. Instead of giving me the radius, I have to figure out the radius, because what they've told me is my center is the origin and the circle passes through the given point. So I know the distance from the origin to the point will be equal to the radius. So I know that h is equal to 0, k is equal to 0. In each case, h is equal to 0, k is equal to 0. And I want the distance from 0, 0 to negative 9, 2. So I know that my distance will be equal to the square root of negative 9 squared plus 2 squared. So my distance will be equal to the square root of 81 plus 4, which would be 85. Root 85. Now what's nice is that I'm going to square this anyway, so I don't really have to worry about the radical. X squared plus y squared is equal to the radius squared, 85. Equally, I could use the equation, right? X squared plus y squared equals r squared when my center is the origin. So I know that 0 squared plus 25 squared, or 5 squared, equals r squared, so 25 is equal to r squared. If I write my equation, x squared plus y squared equals 25. So you may ask yourself, well, why do I use the distance formula here, but I use the equation of a circle here? If you remember, they're not different from each other. The equation for the circle is essentially the Pythagorean theorem, and the distance formula is also the Pythagorean theorem, so it's not weird or different. So I can either use the distance formula to find the radius, or I could take the supplied values of x and y and my values of h and k, plug them into the equation of a circle, and I'll find the radius as well. Okay, so let's take a look at that when we're not centered at 0, 0. So I have a circle with a center at 9, negative 1, and a radius of 2. Well, that's pretty simple. I know that I'm working with this, x minus h is 9, x minus 9 squared, plus y minus k, y minus negative 1 is y plus 1 squared, equals 2 squared, which would be 4. Okay, now if they had supplied me with a point, I would have taken h and k and plugged them in here. I would have taken my x-coordinate and my y-coordinate and plugged them in here, and it would have equaled the radius squared, so I could have then rewritten it with the radius. Okay, so it's not that they're different, it's the same basic process. So go ahead and practice that. Do problems 24, 26, 39, and 40 from section 8.3, and do problem 13 from 8.6. Come on back and we'll finish out this lecture. Okay, so a cellular phone tower services a 10-mile radius. I get a flat tire 4 miles east and 9 miles north of the tower. Am I in the tower's range? So one of the things I could look at, if I'm going to graph this, if we say this is where the cell tower is at the origin, and then we think about my circle. Now I happen to know that my grid is a 10 by, goes 10 up, 10 down, so I know that it's basically the full size of this guy. So it still needs to be just a little bit bigger. Okay, so there's my cell tower with a radius of 10 miles. Okay, I put my cell tower in the center. That's where my tower is, and it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in all directions. So now if I want to look at 4 miles east and 9 miles north, well, there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it's right on the bubble, right? So I would say, yes, I am preliminarily. If I wanted to make sure, I would check the distance from, right? I would have to go ahead and say 4 minus 0 squared plus 9 minus 0 squared. So I've plugged in h and k, my center, and my points, 4, 9. Does that equal, is it less than or equal to 10 squared? So is it less than or equal to 100? So this would be 16 plus 81. Is that less than or equal to 100? So this is 97 is less than or equal to 100. So yes, I'm in the cell range. So if I continue, if I fix my flat tire and I drive south, for how many more miles will I be in range of the tower? Well, we were up here at 4, 9. By the time I get to 4, negative 9, that's probably about the limit of the tower. So I would say I could drive about 18 miles. So 9 down would get me to here, and another 9 down would get me to here, and then that would be about how far I could drive. So approximately 18 miles. Okay, so that's it for graphing circles. In the next section, we're going to work with ellipses.